This is a great shot of a H-bridge. Trigger timing, this motor. Comes from these guys. But this is really a tutorial on a H-bridge. What I'm using here to power it are decade counters. They are called 4017s, and they're made famous in sci-fi movies from the 70s by producing a set of flashing lights. If you've ever seen something on top of a police car or a science fiction movie helmet where you've got 10 lights, they flash forwards and they flash backwards one at a time, like that. That's called this famous decade counter. Very old chip, very reliable, and I'm using them because they take a sharp trigger impulse very well. The timing I'm getting to this motor are from these magnets, and two more on the other side. And each time a magnet passes the Hall effect sensor, those Hall effects will send a trigger pulse to my decade counter. And every trigger signal it gets, it switches to another LED, and so forth. But you don't have to use 10. I've limited the number to 4, and I've gotten rid of the LEDs. So instead of 1 LED, 2, 3, 4, it's one transistor off, second transistor off, and then it repeats. One transistor, then off, second transistor, then off. So it's a very easy, simple, reliable, precise timing tool. And the transistors it's triggering is my H-bridge here, which is coming from this power supply, currently driving 100 volts at approximately 20 milliamps, but the duty cycle is not 100%. The duty cycle is only about 70%. So 100 volts, 20 milliamps, 70%. It's running at about 1.2 watts, give or take, a bit over a watt. Now, the irony of this video is, of course, that I'm making a H-bridge video tutorial, because I don't want to make a tutorial about my free energy machine, because no one ever watches them and no one cares. The irony, of course, is the free energy machine isn't working very well because the H-bridge isn't working very well. It's a brilliant H-bridge, but this motor produces enormous spikes, and that's causing me issues. But I'm going to persevere with this tutorial because it's actually an extremely good H-bridge. Very rugged, and I haven't managed to really destroy much of it yet. The basic transistors, these guys here, the big guys, I've got a wide variety of different transistors I can use, but I'm using a lot of these anyway, twice as many as I have to. The main 4 are triggering it. What we've got is top 2 and bottom 2, and the motor's in the middle. So I guess you know what a H-bridge does, but if those two trigger at the same time, it creates a path like that, and the motor's in the middle. So, and then it turns off, and then these two trigger, creating a path through the middle. So that's making the motor spin in opposite directions, and this magnetic pole's reversing, pulling the magnet into a circle, into a rotation. Now, these huge transistors are in a Darlington pair arrangement. I use a lot of them because they're good for 1500 volts, and they're only $1 a piece. And the signal to power those is being produced by these little guys, BD139. These two components are very generic, very popular, and just general purpose very readily available, very cheap, and really good. And they're the kind of components I like working with. They make life a lot easier, and you get to know them after a while. You can apply them to almost all projects you use. There's a million different types you can use, but if you get good at putting a few different types to use, then your projects are going to work a lot better because you really know how to use them effectively. And the optical isolators obviously are driving it, being triggered through there. And very good setup. Very pleased with it. Now I'll go on to explain the problem, which is the 200 volts point here is the point at which I reach when it starts misbehaving, because as you can see on the scope, I can deliver 100 volts in these pulses, and that's the sort of straight bit. I wonder if you can get a better view at that. They're those little straight bits of a peak of an otherwise sine wave. That's what I'm doing, powering the motor, and then the odd geometry of this motor, the huge amount of copper and huge magnets, mean that the motor actually powers itself. And the magnets supply this extra power, which help the system rotate, and they make the motor more efficient. But they also make it incredibly difficult to actually drive. Historically, these motors are all driven by mechanical contacts, which limits the speed, which limits the usefulness. So I've got a few different ideas I want to try to see if I can get this thing running at any more than a couple hundred volts. Because after I put 200 volts through, or actually 160 strictly speaking, as soon as I hit 160, the extra peaks bring it up to 320, and that finds its way through the diode and actually hits a point where it just starts slowing the motor down. So it runs much better at 140 volts than it does at 160 volts. So yeah, that's a real shame. But yeah, the H-bridge is great. And I've got some really posh new silicon controlled rectifiers, some hardcore transistors I'm going to try next. So yeah, this motor, not a lot of torque, at least not at 1 watt. I can, slow it down pretty easily, especially with the motor and the chain dragging it down at 1.2 watts. I only just connected that up, but without the motor, I'm unable to stop it squeezing that little shaft, so it's really still got quite a lot of power, but we need more speed in order to achieve more usefulness, so that's good. Check back in a week's time, like, subscribe, and be independent from the barrel meisters of this world. Let's bang them over it instead.